Hi, this is problem 8 from the 2020 AIME 1. A bug walks all day and sleeps all night. On the first day, it starts at point O, faces east, and walks a distance of 5 units due east. Each night, the bug rotates 60 degrees counterclockwise, and each day it walks in this new direction half as far as it walked the previous day. The bug gets arbitrarily close to the point P, then the length OP squared is the reduced fraction m over n. Find the sum m plus n. All right, let's try to diagram this out. So on the first day, we're going to start from point O and travel 5 units due east. And on the second day, we're going to change our direction 60 degrees and travel 5 over 2 units in that direction, turn another 60 degrees, travel 5 over 4 in that direction, turn another 60 degrees, travel 5 over 8 in this direction, and we're just going to spiral in these hexagons down to a final point P, and we're trying to find the length OP squared. So it seems as though we could try to attack this problem using some type of vector addition, but we can also add these line segments in the complex plane, and that seems to be a little bit simpler, so let's try that approach. So let's imagine we're in the complex plane. We'll set O at the origin. This will be our real axis. This will be our imaginary axis. So this first number is just the number 5 along the real axis. In the complex plane, from de Moivre's theorem, we know that rotating 60 degrees is the same as multiplying by e to the I pi over 3. So that represents the second number in our series. Rotating another 60 degrees is e to the I pi over 3 squared. So that's our third number in the series. The fourth number in the series is 5 over 8 times e to the I pi over 3 cubed. So we sort of see what's going on here now. So let's call this number z for convenience. So the series we're trying to determine is now 5 times 1 plus z over 2 plus z squared over 4 plus z cubed over 8, this infinite series. So pulling out our formula for an infinite geometric series, we find this equal to 5 times 1 divided by 1 minus z over 2. Multiply top and bottom by 2 gives us 10 over 2 minus z. Let's see, we'll have to substitute in what is z in Cartesian coordinates. So converting e to the I pi divided by 3, we find that that's 1/2 plus root 3 over 2i. So plugging this in for the number z gives us 10 over 3/2 minus root 3 over 2i, multiplying top and bottom by 2, 23 minus root 3i. So this represents OP in the complex plane. We're trying to find the square modulus of OP. So that's equal to the square modulus of the numerator divided by the square modulus of the denominator. So we find that OP squared is just 20 squared divided by 3 squared plus 3. That's 400 divided by 12. Can reduce that down to 100 divided by 3. 100 plus 3. 103. Final answer.